Hello all of you. Now welcome to the next class of this physical quantities. In our previous class we have discussed about the definition of physical quantities like speed, distance, rest and motion. Now we proceed to the velocity. What is velocity? Velocity is the vectorial form of the speed. That means distance covered by a body with respect to time in a particular direction is termed as velocity. Velocity is a vector quantity, so it has both the magnitude as well as direction. So, if velocity you got to say, then velocity will be dx by dt in vector form. There dx is the small displacement and dt is the small time. Like speed, velocity is also three types. One is the uniform velocity. Next is relative velocity, and also it has average velocity. Uniform velocity, when the body covers equal displacement in equal time interval. Again, the nature of graph of uniform velocity will be a straight line inclined to the origin. So there, if you write here this d for displacement, there t for time, then this will be the acceleration of the body. But here, the motion of the body is in uniform nature. Relative velocity, as we have discussed in the case of speed also, when the velocity of one body with respect to another body will be termed as relative velocity. Relative velocity in a plane, relative velocity in a straight line, we will discuss in our next chapter. That's the introductory part. There, velocity will be VAB. If you are writing, then we will give the vector form because it's a vector quantity. So it's a VA minus VB. Average velocity, when we are talking about, then average velocity will be total displacement covered by total time taken. Total displacement covered by total time taken. Average velocity and average speed, there is a bit of difference between this, because in case of displacement of a quantity can be zero, but distance of a quantity can be zero if the motion is not taking place. Otherwise, if a body has covered some distance, then the distance can't be zero. Like in a circular track. In a circular track, if you are talking about, then the body has distance. It started from A and finally it has reached to B. Then what is the distance covered by body? In this case, the distance in a circular frame will be 2 pi r. Where r is the radius of this origin to the boundary. But in such case, if the body has started from A and reached to B and will ask what is the displacement, then displacement will be 0. Displacement will be 0. So, the basic difference between the uniform speed, relative velocity, average velocity are there. We are talking about vector quantity. On case of speed, we are talking about scalar quantity. So now we'll move to the next part, that is the graphical representation of motion. Before that, we will discuss why we need graph. Graph help us to compare the two or more quantities. Just like two bodies are moving, either they are approaching or they are moving far from each other, then what is the nature of the relative velocity between them, or which body is moving faster than the next one? So graph helps us to compare the whether the body speed is increasing or decreasing, at what time its instantaneous velocity or instantaneous speed is what. It can be easily calculated by the nature of graph. So we have two type of graph here. One is position time graph, position time graph, and next is velocity time graph. First of all, we'll move for the position time graph. There, time will be kept in x-axis and position will be kept in y-axis. So, when we're talking about position time graph, then we have to discuss about the nature of the position of a body. Suppose we are talking about a body at the condition of rest. So, when the condition of rest is there, then there will be no changes on the position of the body. That means with respect to time, the position of a body is not changing. So the body is at pure rest. So first we will draw the position time graph for a body at rest. This is position, this is time. Suppose the body has covered time 1, 2, 3, 4 and so on, and this is the position of a body with respect to given frame. If you're talking about that the body at certain height is there, then after 1 second the position of body will be there, after second time the body will be there, on third second the body will be here, the fourth second and so up to the body will be there. That means the nature of graph will be a straight line parallel to the time axis. For position, when the body is at rest, the position time graph will be a straight line parallel to the time axis. So we will not give any other quantity by this because there is no any inclination. So when inclination is not there, we can't get other quantity from this given graph. Only we can conclude that the body is at rest. Now move to the second part, the position time graph of a body when the body is in uniform motion. That means the body changes its position equally with respect to the time. So position time graph for a body for uniform motion. When the body is at uniform motion, means for first, second, third, fourth, so if in every second body is covering a distance of 2 meters, then for 2, 4, 6, 8, 10. After first second the body is at 2, for next is 4, third is 6, fourth is 8, next is 10. So if you plot a graph from the origin, the inclination will be a straight line inclined to the origin, which concludes that the body is in uniform motion. Now next graph, when the body is in non-uniform motion. Body is in non-uniform motion. That means position, here position you can write distance as well as displacement, because numerically for a straight line motion, the distance and displacement are equal. So when the body is at non-uniform motion, so either the body can be in increasing order or in decreasing order. It may take any shift because here the motion is non-uniform. So suppose the body is covering 2, 4, 6, 8, 10. First it has gone for 2, second it has reached to 6, third it has again come to 4. 3 cases are there. So if you are plotting, the nature of graph will be like this one. It can take any shape depending upon the position and time. So 3 graphs are there for position, time, axis. The same graph, if you are talking about that body is starting from certain speed and then after uniformly it is decreasing its speed. Body is moving with certain speed and after that it is decreasing its speed at a certain frame. So on that case, the nature of graph will be like this. It is started from some velocity, it is moving with some velocity, and finally it is decreasing in equal ratio. Then the nature of graph will be like this one. If the body is starting from the left of the origin, then the nature of graph will be like this one. Here the body is starting from the different origin. So position time graph has different type of frame. We will give our assignment there also. I will try to cover so many type of other graphs, and you please try to write it down on your copy. That graphs will help us to solve various type of numerical, and also it will help us to interpret some type of message from this position time graph. So our next graph will be the velocity time graph. Velocity time graph. If you are talking about velocity time graph, then the first case, when the body is moving with constant velocity, that means its speed is not changing. Whatever speed it has taken, it is continuing on that speed. So velocity time graph for body moving with constant velocity, constant velocity. So once again, the nature of graph will be this time VT, velocity time graph. The nature of graph will be a parallel line parallel to the time axis, a straight line parallel to the time axis, because its velocity is not changing. So if it has certain velocity 10, 20, 30, 40, then it is maintaining that speed. So the straight line represent that there is no any change in the velocity of the body. Second case, when we will talk about when the body is moving with uniform increasing velocity, uniform increasing velocity. Uniformly, body is increasing its speed, but that is uniformly. So again, the nature of graph will be a straight line inclined to the origin, and we can get other quantities from this. Like, what does the slope of velocity time represent? Slope is the ratio of v and t. So ratio of v and t, which quantity it is? Yes, it is acceleration. So we can get the acceleration of this quantity with the slope of the obtained graph. Next graph will be when uniformly decreasing velocity, uniformly decreasing velocity. It has some velocity and now it is decreasing. So the nature of graph will be like this one, velocity time. On this graph, it will ask what quantity we are getting by the slope of the graph. Yes, it is retardation because it's the acceleration in opposite direction. So velocity is decreasing. So there it's the minus a is v by t. The minus shows that the velocity is getting decreased. So it's a retardation. We have other so many type of graph based on this. Let's see. Now, position time graph. If we are representing position time graph, then one question arises so many times in our brain, that is it possible to have a position time graph of a body like this? Please pause the video and think for this. Try to think the answer. Yeah, somebody has got it. It's not possible because just look at this origin, the body is at two position. In this time, suppose it's a 1, 2, 3, 4, and here it's a 2, 4, 6, 8, 10. At 4th second, the body is at 2 position, which is absolutely not possible. Again, the position time graph of a body, position time graph. Can it be a position time graph of a body? Again, please pause the video and try to think. Yes, it is possible because just look, it has different origins. So the body has one position at a certain instant of time, so it can be a position time graph of a body because moving with variable speed. What will be the graphical representation of a body, two bodies, when moving with zero relative speed or velocity? That means two bodies are there, they are moving with respect to each other, but the relative velocity between them is zero. That means no one is catching each other. So if you are talking about certain velocity, the body has this one also is certain velocity. So these two lines will be a parallel line. That means they will never intersect each other. And if they are never intersecting each other, they are uniform. The relative velocity will be zero. Relative velocity will be zero. But when two bodies relative velocity are intersecting each other, that means they are crossing each other. So in that case, the nature of graph will be at this point. If suppose this B and this one is A, the body B has chased the body A. So please, dear children, try to revise the graph. I'll provide you the assignment and questions also. Try to sort out all the questions there, and if you are getting any doubt at any part of the things, feel free to message me on my WhatsApp number. Thank you.